Assalamualaikum and good morning to the lecturers and my fellow friends. Today, our group, which is Group 11, will present about the engine technology. The first engine technology is Campro engine. Okay, the Proto Campro engine is the first flagship automotive engine developed together with Lotus by the Malaysian automobile manufacturer. Here is the evolution of the Campro engine. The first Campro engine made its debut with Campro dual overheat cam or Campro DOHC. It made its debut in 2004 fit to the Gen 2 models. Next is the Campro CPS and IAFM. This Campro engine system using the variable valve lift and also the variable length intake manifold. Okay, next is the Campro CFE. This Campro CFE stands for the charge fuel efficiency. The Campro CFE engine is the light pressure intercooled turbocharged version in the 1.6 liter Campro engine. It will maximize boost pressure of 0.75 bar. Okay, the last version of the fourth version is the Campro VVT. The VVT stands for the variable valve timing engine that is unveiled in the September 2014, and its first application is in the Proton Iris. This system has a new block, new piston, new valve, and also incorporates variable valve timing. Okay. The Campro engine that to be highlighted today is the Cam Profile Switching System, which is CPS. Here is the example of the engine. Okay, this system use a 3-loop camshaft to switch between two different cam profile. Firstly, it is a low lift. The low lift cam profile is used at the low to mid engine speed to maintain idling quality, and it also offers a fuel efficiency with low emission. Then there will be a sliding mechanism inside the cylinder after lift response to the tappet, and here is the tappet. And finally is the high lift. The high lift cam profile is used when the engine is spinning at mid to high engine speed. It will improve the peak horsepower and also torque to maximum power. Here is the video of the 3-loop camshaft and also tappet. Okay, here is the 3-loop camshaft system, and here is the position of the low lift, and then a sliding mechanism which is tappet will slide to change to the high lift. Okay, and lastly is the advantage and disadvantages. The advantage of the CPS system is it is lower cost, and also the simple of the engine is the design of the engine is simple, more simple compared to the others variable valve timing engine such as Honda and also Mitsubishi. But it is also have the disadvantage, and the implication of this engine is lack of variable lift and also variable valve opening duration.
What is VVTI? VVTI, or Variable Valve Timing with Intelligence, is a variable valve timing technology for automobiles designed by Toyota. It is Toyota's most advanced variable valve timing (VVT) system for engine modulation and control. The background of VVTI. VVTi debuted in 1996, adding intake valve timing to the VVT cams casing and has since been the standard in most of Toyota engines lineup. VVT was first used in the 4A GE engine, which has 5 valves per cylinder and a two-stage hydraulically controlled cam casing system in 1991, and it swiftly spread throughout Toyota engine portfolio. VVTi deliver optimal valve timing dependent on driving circumstance by continually altering the open or close timing of the intake valve. VVTi also has several variations including VVTLi, VVTIE, valve-matic, and dual VVTi. There is three major components in a VVTi, which is one, electronic control unit ECU, calculate optimal intake valve timing based on engine operating condition. Second, oil control valve OCV, control hydraulic pressure under the ECU instruction. And third, WT pulley, change the intake valve timing continuously using hydraulic pressure. So how VVTi system works? VVTi ensures timing control by altering the intake valve opening and closing height and duration not only through the camshaft lifters but also by managing the duration through change in the camshaft rotation. This allows regulation of the overlap period between intake and exhaust valve closing and opening on a dual overhead camshaft system DOHC that controlled by a variable speed head in this setup. The timing system, belt, scissor gear or chain, provide a rotational force to the camshaft through this head or camshaft gear. Gear head is a hollow structure with adjustable oil pressure that allows a two-piece floating system to speed up or slow down the head's rotation in relation to the actuator. The camshaft gear's outer gear connects it to the belt or chain that drives it, and the camshaft is connected to the inner gear. The two are normally machined together, cord against cords, and turning at the same rate. However, when oil pressure is applied, the gears can be separated, changing their speed relative to one another for a brief period of time. The camshaft speed is increased or decreased in response to the engine drive timing. As a result, the period of valve lifting to govern intake and exhaust change. Now, the advantages of VVTi Toyota, the first is fuel economy. It is improved, and nitrogen oxide and hydrocarbon emission are reduced. The valve overlap the time when both the intake and exhaust valve are open, which is achieved through continuous regulation of intake valve timing based on engine load and speed, improve fuel economy, and lower nitrogen oxide and hydrocarbon emission. During partial load on the other hand, an engine with VVTi enhances the timing for opening the intake valve, increase valve overlap, and draw partial exhaust gas back into the cylinder. When the engine is idle, the valve do not overlap to stabilize combustion, and the idling speed is reduced to enhance fuel economy. Second, increase in torque and output. The intake valve timing is given optimum, continuous, and broad control based on engine speed during high load driving conditions that necessitate high torque and output. The timing intake valve pressure must be determined in relation to the intake initial effect and the intake air return induced by a rising piston in order to increase the amount of intake air. Timing changes optimally in response to engine speed. The VVTi engine boosts low and medium speed torque by managing intake valve closing ahead of time in the low and medium speed range. To boost output, the timing for shutting the intake valve is delayed as engine speed increases. Disadvantage of VVTi Toyota engine is not appropriate for high revving and automobile engine. For high revving driving, the responsiveness to altering valve timing is not as good. It is unable to respond more quickly for this goal. As a result, rather than improving car performance, it will most likely lose its power and acceleration.
Assalamualaikum and very good day everyone. So the DAT system will be variable valve timing electric control, or as known as VTEC. For Honda lovers, these engines are very familiar and popular since 1989 until this day. So Honda has do a very great job in R&D of VTEC to keep it relevant for today's industry. So, what makes this system or engine very iconic? Let's dig it. For the history, Honda developed this VTEC that leads by their engineer Mr. Ikuto Katijani, and this VTEC has been focusing on increasing volumetric efficiency where the engine will be high performance and also fuel safe in the same time. VTEC also will be very practical for both types of driving, fast or slow, high RPM or low RPM, high power or low power. VTEC also have various types of engine such as VTEC E, VTEC Turbo, and iVTEC, and the legendary K series K24 and K20A. So what VTEC offer to the engine? So, the common daily use engine, which one the fuel saving engine, usually are not able to produce such as high power and also a high acceleration to the car. But for the car that occupied by high performance engine which produce a very high torque and horsepower, usually are not fuel saving, and it will cost a lot of maintenance. Thus, that's why Honda developed VTEC. VTEC will offer solution for that common problem, where this system will control the intake valve opening according to how fast we want to drive, how many power we want, and also it will save the fuel consumption. So with this figure, we can see the difference between VTEC and also normal valve train system, where the VTEC usually has two different cam profile and also two different rocker arm. This different cam profile will controlling the opening on intake valve, where it will open smaller when you drive slowly and will be open larger when you drive in the high speed mode. So let me show to you the simple mechanism how VTEC operate. So when you drive in this normal speed or below 4000 RPM, the normal cam profile will connect to the intake valve, where the intake valve will only open smaller. So less air entering the engine chamber, resulting the less combustion occur. So the system will save the fuel usage when you drive in the normal speed. But when you want to go accelerate, for example, you driving in the highway and you want immediately torque or power, the ECU or electric control unit will detect a change on oil pressure, temperature, speed, and your throttle position. So it will make the rocker arm change the cam profile to the high performance setting. This will cause your intake valve open larger than normal opening, and resulting more combustion occurs that produce high power, so your car will accelerate smoothly. So this simple mechanism show that this VTEC is very intelligent system, where it can operate greatly in low RPM or high RPM. So you can use this engine or system in the car that used in the daily drive in the town or city, or also to the road trip in the highway. This is the reason why Honda car with VTEC are very popular in the Malaysian road. So let's talk about the bad side of VTEC system or engine. So as we know, VTEC is very complex engine with many component inside it. So the engine will be very high maintenance and also expensive to build. And when the engine are occupied with many type of component, it will be very risky to see the engine broke or maybe overhaul. So for everyone who have VTEC engine, you should know how to maintain it and taking care of it.
Assalamualaikum and very good day everyone. So in our opinion, the best engine for the technology is VTEC Honda. So first thing first, basic mechanism is first one is the basic mechanism used by VTEC technology is hydraulically actuated pin, and the second one, pin reached to rocker's arm. The third one, a spring mechanism used to the pin bag, and the last one comprises of the two camshaft locks. So the principle of the VTEC Honda, one of the cam lock on the left hand have a wider profile, opens its valve earlier. Second, for more time and close it later in compared to the others. And lastly, the fuel is allowed to enter through one valve completely while others valve open partially. There's a four type of series VTEC engine. For the first one is SOHC VTEC, and the second one is VTEC E, and the third one is iVTEC, and the last one is 3-stage VTEC. So let's look to the VTEC E first. So VTEC E implementation is for the economy. Users willing to promote more efficient air fuel mixing in engine chamber. Moreover, only one intake cam lock uses, and last one, making engine to operate in valve working mode. So the next one is iVTEC. The iVTEC intake camshaft is now capable if advancing between 25 and 50 degrees. Facing is implemented by a computer control or driven adjustable cam gear. So basically iVTEC basic that include Honda cylinder deactivation technology. So what are the advantages? The first one is better fuel efficiency. VTEC also has high initial torque with relevant high power, has lower emission, and also has strong performance and have various type of mods and can achieve most power by natural aspirated. So what kind of feature of VTEC? First one, implementation on performance engine, better opportunities on higher petroleum, and consideration on its advantage, and last but not least, economy and certification to be estimated. So that's all from us. Thank you.